Welcome to 3.6 surface area of...
Oh, composite figures. Sorry, I didn't realize we were recording.
Yeah.
Composite figures, isn't everything in the world a perfect cone or perfect sphere or perfect rectangle?
No, actually, you can see figures that are made of multiple types of objects all over the place. Take like a house, for example, if you need to calculate how much siding you need or roofing, because those would cover areas. The shapes aren't necessarily going to be just straight up prisms or straight up pyramids. They're going to be combinations of these things. It's going to be fairly intense.
Dang. Well, I'm really excited to see this first example. Oh, hey! I purchased a perfectly spherical scoop of ice cream nestled exactly halfway into a tasty waffle cone. I wish to cover it in a magical wrapping paper that doesn't need any taping or overlap so that I could give it to my friend, Mrs. Friesen. The cone has a diameter of 10 centimeters and a slant height of 24 centimeters. Yeah, it's a pretty amazing gift. What is the exact amount of wrapping paper required? Okay, so the first thing I'm going to do is probably going to be drawing a picture and then labeling it with the measurements that I have. So I'm going to draw my waffle cone. And my waffle cone is brown in color. Apparently spills outside the lines there, but you know, we can't all be perfect. And then I have ice cream, and I'm giving to Mrs. Friesen. I don't actually know what her favorite ice cream flavor is. I'm going to say pink. And it's a half sphere because the rest of the sphere is perfectly inside of there. So it's just a half sphere popping out. And again, we need the appropriately colored ice cream to really get the whole sense of it all. Now that I have my ice cream appropriately drawn, I'm going to be labeling my diagram with the units and the values given to me in the question. So I know that the diameter of the cone, so from here to here, is going to be 10 centimeters. What else do I know? I know that the slant height, so from here to here of the cone, is going to be 24 centimeters. And those are all the values that I'm given. Something that I might notice is that I'm eventually going to likely need the radius, and the radius can be found by just taking my diameter and dividing it by 2, so 10 divided by 2, which is 5 centimeters. All right, so taking a look at this, I'm going to write a formula for my surface area of my composite shape. So my surface area is the side area of the cone. So it's like a whole cone, but without a base, because the base would be where the ice cream is. But that's not on the surface. The ice cream's there in the place. So I'm going to say, well, side area of cone. And, of course, I have my area of the ice cream. And my ice cream itself is a half of a sphere. So I'm going to say plus half of the area of a sphere. Right? So just so that we're clear here, this is coming from this pink portion, which is now highlighted in yellow, and this part of the equation is coming from this portion. Alrighty. Now, when I'm looking at my formulas, or my formula sheet, my side area of the cone, so if I'm looking at the whole surface area of a right cone or right pyramid, I have base plus perimeter times slant height over 2, but I don't have the base in this case, so I will just have perimeter times slant height divided by 2. So perimeter times slant height divided by 2. For my area of the sphere, well, I know my area of the sphere is 4 pi r squared, and here we have it. Now, continuing down, I don't actually know what this P value is. I can't plug that in directly, but P stands for the perimeter of my base. Because I'm talking about my cone, even though this base is on the top here, it's still considered to be a base. So my perimeter of my circle is going to be 2 pi r. So I'm just going to replace that capital P with that. Then I'm going to maintain everything else here. Alrighty, so just to make that super clear, that 2 pi r is really equivalent to that capital P. It's the perimeter of my base. Now I'm going to just go ahead and plug in some values. So instead of r, I know my radius was 5. Instead of my slant height, I know that was 24. And moving on here, I know again that instead of my radius, I'm going to put 5, and that's still squared. Now I'm going to go ahead and multiply everything except pi right now. So I'm going to go 2 times 5 times 24 divided by 2 will give me 120. And of course I still have to multiply by pi. I have the personal preference of doing that at the end. And in my area of my half a sphere, I have 5 squared, which is 25, times 4, which will give me 100, times by a half will give me 50. So I will end up with 50 pi over hither. Now, I'm going to add those two things together, and I get 170 pi. And notice that the question asked me what was the exact amount of wrapping paper required. So I'm going to leave it in terms of pi, but I do in fact need to make sure I include my units. So my units, since I had centimeters in all of my measurements, an area has units of my units squared. So I'm going to have 170 pi centimeters squared. Now I do need to have a final sentence here because it is a word problem. So what is the exact amount of wrapping paper required? Miss T, that's me, will need 170 pi centimeters squared of wrapping paper. One thing that I will mention prior to kind of passing on the torch to Mr. A for him to talk about his gifts, but I would like to point out that you can do these two things separately. So if you wish, you can do this portion over there, this portion over here. As long as you add them at the end, you will and should get to the final answer that is the same. I personally like to do it in one giant equation, but again, personal preferences, so up to you.
Of course, just make sure when you're doing so that your work is very well organized and you're clearly indicating what you're doing at each point, that it's easy to follow, easy to read. In this next example, some person named Mr. A, hey, that's me, has given Mr. O'Donoghue a most beautiful aquarium. You can actually see it in the physics lab. The base looks like this. That's what it looks like from like a top-down view. That's what you're seeing. And then there's glass that extends from the plastic base to the plastic lid, and that has a height of 60 centimeters. So if you're having trouble picturing this, essentially like we've got this thingy here, and it's also there, and there's your whole tank or aquarium. That's what it looks like, right? We've got this shape at the top, we've got that same shape at the bottom, boom, yada. And this height right here is 60 centimeters. And that's what we're looking at. I actually kind of like this diagram. It's pretty sweet. I might just keep it, but shrink it. Dope. So what is the area of the glass used for the aquarium? And this is a surface area question. So if we're talking about the surface area of a prism, we're talking about 2 times the area of the base plus perimeter times height. Remembering that this 2b is because there's a bottom base and a top base. And then pH is from saying we're going to have all of this stuff going around the outside of it being multiplied by the height, because it's really just a giant rectangle going around there. In this particular scenario, though, we're just getting the area of the glass, and that doesn't include the base at all. It's a plastic base and a plastic lid, and glass will attach the two of them. So in this particular case, we can cross that out. We can say but there's no base included in this case. Because they're plastic. At this point, we can break this into pieces. Let's talk about what the perimeter is. And that perimeter is, we've got 90. We've got 22.6. 90 looks like this. We've got 18. We've got this 122. And then over here, that's our 18 again. And then over here, there's our 22.6 again. And all in all, that's giving us a perimeter of 293.2 centimeters. With that knowledge then, we can say, in the same pink that we had before, that the surface area, since it's perimeter times height, is going to be 293.2 being multiplied by this height of 60. And this is just from upstairs there. Oh, wait. That gives us a value of, according to my head brain, 175.92, or 17,592 units. We're looking at centimeters times centimeters, so square centimeters. And of course, I'm going to give a wordy word answer here, because I like my words. So the area of the glass that's used for this aquarium is 17,592 square centimeters. There is some practice work for you to play with. It's a little bit in the textbook, so 2 questions from the textbook, but there's also some fun questions here, which are probably the most exciting questions on that page. So those are worth a look-see. Don't forget to ask us questions via Teams or in class as you encounter them or as they come up. Let us know what you're thinking and how things are going.
Just remember that you can do anything, especially math. And we hope to see you in class and answer all those questions soon.
Woo!
Adios, muchachos.
Goodbye.